Okay, good. So, welcome to our last topic, that is in Introduction to Statistics course. So, we are going to cover that is inferential statistics in this that is in this topic. Okay. So we are going to finish with distribution, that is in statistics, and also we'll be able, that is to enter one last topic, which is hypothesis testing. Okay, so hypothesis testing will be, though it is a one class topic, so that's why it won't take much of our time. But under distribution, it is very much involving. So we'll have that is to take it through this week, okay, and then we shall finish next week maybe with the practicals on distributions. Okay, last week we'll finish that is with the practicals in that is under distribution or under inferential statistics. So here we, as you know, we have very many types of distributions. Okay, we have that is student t distribution, we have chi-square, we have Poisson distribution, we have Gaussian distribution or the normal distribution, we have exponential distribution, we also have binomial and binary distribution. So those are just example of that is the many distribution we have. Okay. However, in our introductory or in this class, we are going to focus majorly on the that is on the major distributions. Okay, the four major distribution, and that is we are going to discuss about our great and famous normal distribution. Okay, normal distribution. Normal distribution, almost maybe if you are in school, it almost uh, applied in every aspect, okay, of our life. May it may be the height of the student in class, they follow normal distribution, the weight of the students in the class, the cut scores in maybe your class, also the length of your arm, okay, or the length of student arms in the class. So normal distribution, it's like we use it on what, on that is on day to day that is basis. Okay, so that's kind of what, that's kind of that is all one distribution we are talking of, that is the normal distribution. It has very many applications. Okay, then we'll also discuss about a second distribution, that is binomial distribution. Binomial, binomial distribution. Okay, so for binomial distribution, basically we'll consider that is any experiment with what, with success, okay, and what, and failure. Any that is example or application with success and with what, and failure, and with also some trials. Okay, with also some what, trials. Okay, nice. We also need another that is type of distribution. That is we learn about Poisson distribution. Poisson distribution. So also during that is our study, you'll see that we have different properties, okay, of these distributions. Okay, we have different properties, and maybe just a heads up is that now when it comes to examining of distributions, but that is in your final exam, uh, you won't be that is examined more of what, more of practical. No, they won't bring any practical, okay, to do that is for no, for these distributions. But they will test you on the properties of the distribution, properties, okay, properties of the distribution, and they will also test you on the applications, okay, application. Maybe they can give you an example, okay, like you maybe we have a data set for that is for 20, maybe class of 2019 scores, okay, which kind of distribution can this data assume, okay, maybe you will be given binomial distribution, Poisson distribution, normal distribution, or Bernoulli distribution, okay. Yes, so majorly for up to now, they after doing the that is the evaluation, they have been testing more of the what of these properties and applications. Okay, so it's also good to keep this in mind. Then we have Poisson distribution. For Poisson distribution is also known as count distribution. Why? Because it gives us the count of what? Of the events occurring within what? Within a period of time. Number of events occurring in what? In that is in a given time period. Okay, so with this maybe we'll be able to calculate some probabilities, like we want to know the probability of maybe let's assume you are working on that is an outlet, that is a cookie outlet, okay, cookies outlet, and we know that is from the historical data, we have that is data that every it's only Fridays where we usually get what, where we usually get the highest what, the highest that is number of customers, okay. Let's assume on Fridays we usually or Friday night, okay, let's assume now, let's narrow it to even time interval, okay. We are assuming on Friday nights we usually that is receive, or we usually get 200 to 300 cookies orders, okay, cookies order or orders, okay. So with that, we will be able to what? We can also try to calculate that what is the probability that this the number of the cookies, okay, in next or that is that is next Friday. We are assuming what will be the probability that will have more than what, 400 what, more than 400 cookie orders, okay. Yes, so we are trying to check the probability of a certain number of events occurring, okay. We'll also discuss that is the Bernoulli, and Bernoulli, it's a special what, it's a special type of binomial distribution, like it takes place when that is n is equals to what, 1, okay. When n is equals to 1 in normal distribution, it now changes from what, binomial distribution to what, to Bernoulli distribution. Also on normal distribution, it's also known as Gaussian distribution or the bell curve distribution, okay. So with these are the major four types of distributions which we will look at, okay. And if the time allows us, maybe I can add exponential distribution, okay, exponential distribution and see some of the properties or some properties of binomial of what of sorry of exponential distribution. Okay, okay, good. That was just an introduction. I just wanted to show you that is the different types of distributions and maybe what they mean. Okay. Yes. Now let's go. That is now to introduce this topic. Okay. So let's start with the statistical distribution. Okay. Something also I forgot to state is we have discrete distributions and also we have continuous distributions. Okay, like for example, normal distribution, it's an example of continuous distribution. Okay, it is an example of continuous distribution. We have discrete distribution, and for discrete distribution we have Poisson Poisson distribution is a discrete distribution, and also we have binomial distribution. Okay, and also Bernoulli distribution. They are examples of what? Discrete distributions. Okay, but we shall check into details that is on the same. Good. Let's start with the type of statistical distributions. Okay, so distributions may vary. Okay, may vary depending with what? Depending with the distribution of your data. Okay, so depending on the type of data we use, we have grouped distributions into two categories. We have discrete distribution for discrete data, whereby maybe we have finite outcomes. We know that is the possible outcomes. Okay, like for example, when we are dealing with binomial distribution. Okay, let's assume we are playing that is the basketball. Okay, yes, that is basketball. Definitely this is the basket. Okay, this is the basket, and this is now the ball. Okay, so we might try to do an experiment, maybe with what? 10 throws, meaning n will be what? Our total number of what? Trials. Total number of trials is n. So let's assume we want to make 10 throws. Okay, inside what? All the throws to go through what? To go through this basket. Okay, good. We have here two possible outcomes. That's why we are saying a finite outcome. We have two possible outcome here. It's either we that is the ball successfully goes through the basket, or the ball fails to go through what? Fails to go through the basket. So we have what we call that is a fail and what? Success. So for successful that is outcomes, we usually use X to represent what? That is successful outcomes. But don't worry, we shall discuss this in detail. So this I was just giving an example of what? Finite that is outcomes. Another example of finite that is outcome is maybe we are rolling that is we are tossing a coin. Okay, tossing a coin, it's either you only have two possible outcomes. Okay, either get ahead, okay, or get what? Get a tail. These are the two major outcomes, or two possible outcomes when you toss what? When you toss a coin. When you roll a dice, we have only six possible outcomes. Okay, so those are just examples of what discrete that is distribution or discrete experiments. Okay, good. Now let's go to continuous distribution, that is continuous distribution. Okay, so for continuous distribution we'll talk about what infinite outcomes, or here our data type might be what, might have floats or decimals attached to them. Okay, like for example, if we want to check the distribution of that is students height in what, in a class. Okay, so definitely that height will follow what, will follow a certain what, distribution. Okay, and with that it's continuous, it's infinite, we can have infinite outcome. Okay, within that data range. Okay, then let's try and start with the discrete distributions. Okay, so for discrete distribution, we have uniform distribution. Uniform distribution meaning it's like we having that is a uniform distribution of what, of the data types. Okay, like for example, when we say the probability of what, let me not use a probability. Like for example, I want to use yes, let's say probability of that is of a fair dice toss. Okay, like if we roll, not a toss but a roll. If we roll a dice, we know we have six possible outcomes. Okay, and those six possible outcomes, they have a uniform what, probability. It's the same as the that is the toss of a coin. We know the toss of a coin, it's either the outcome, it's either a head or a tail. And for this, they will have the same what? The same probability. Okay? Meaning the that is the likelihood, we have 50% likelihood of what? Of head occurring, and 50 percent likelihood of a tail occurring. Okay? So we are 50-50. So at that point, the probabilities will be what? Will be half half. Remember, the probabilities should add up to what? Add up to 1. We cannot get a probability which is more than what? Which is more than 1. If you get a probability of more than 1, then you will have to recheck. You will have to recheck maybe your that is your you are working. Okay. Yes, let me that is introduce this the uniform distribution. You can see this is an example of uniform distribution. So you can see the outcome, it's uniformly distributed. Okay, it's like we are having the same constant what, outcome. Okay, so we are saying that in statistics, uniform distributions refer to statistical distribution in which all outcomes are equally likely. Okay, we have equal that is all the outcomes are equally likely to happen. Okay, so consider rolling a six-sided dice. You have an equal probability of obtaining all six number of what, of or numbers on your next rolls, i.e. you can obtain a one-sided side, a two-sided side, or the that is the three dot sided part, or the four dot sided part, five dot sided part, or a six sided part. Okay, meaning these will have an equaling of the probabilities. Like we are saying that the probability of once we toss that is the or we roll the dice in the first that is the round. Okay, it's possible to get what, that is probability, or the probability of getting that is the one dot sided part, it's 1 over 6. The probability of also getting the five sided what? Five dot sided side or part, it is also 1 point what? The probability will be also 1.6. Okay? Yes. So we are saying that as a result, the uniform distribution graph contain bars of equal height representing each outcome. Okay, like in this example. So you can see we have like a uniform, okay, distribution of that is of the possible outcomes in what? In this kind of distribution. Okay, nice. Most of the time, people confuse that is distribution as what? As graphs. Like when you see that is a curve like this, which is a bell-shaped curve, you say you know this is a normal distribution. If you see this kind of graph, you know this is uniform, that is a distribution. If you see maybe this kind of curve, it's maybe the exponential distribution. Okay, yes, it is true, but we don't only use that is graphs to define what? To define distribution. This means these curves or these graphs, they are only graphical representation of what? They are only graphical representation of our distributions. Okay, but now I want us to do what? I want us to define what is this distribution, or what does it mean by the term what? Distribution. Okay, so we can define distribution as that is probability what? Probability distribution. Okay, so and what is probability distribution? So in terms of definition, probability distribution is a statistical function that describes all the possible values and likelihood or that a random variable will take or can take a value within a given what? Given range. Okay, so basically probability distribution shows us the possible outcomes or the likelihood of a random variable, okay, occurring within what? Within maybe a given range. That's what we call probability distribution. Okay, and this range is also bounded between what? A minimum value and a maximum possible that is value. Okay, like for example, if we are talking about maybe rolling a dice, okay, we know the possible outcomes, okay, range between what? 1 and 6, even though we have what? A uniform distribution of what? Of the probabilities. Okay, but we have possible outcomes, okay, or possible values to that is to occur within what? Within a range. Okay, but prices that is precisely where the possible value is likely to be plotted on probability distribution depends on a number of factors, and the factors which contribute to what? To a probability, or to the that is the how or probability. Okay, the factors that contribute to a shape, okay, or yes, let me say to a shape of a distribution, we only have three major factors. Okay, in fact four major factors. It is the average, okay, of the values. We have also the standard deviation of the values. We have the skewness of the value, and also we have the kurtosis of the values. These are the four factors which determine the shape of our what? Of our distribution. Okay? Yes, these are the major factors which contribute to what? To that is to the shape of our distributions. Any question up to that point, guys? So that we may be together. Any questions or any uh, points maybe you can add from your different understanding? Any question up to that point? Because I want to discuss about now the measures of asymmetry. Okay, sorry, the measures of, yes, the measures of asymmetry. Remember, under the measures of asymmetry, it's the topic under descriptive statistics, which I had told you earlier. I will discuss it when we'll be discussing the distributions. Okay, any question? Any question? Any question? Or yes, Kennedy?
Maybe my question is, where do we usually apply this, the probability distribution, especially in the field of profession that we
Okay,
are?
good, good. So we shall still come to the applications. So we still far from discussing the what? The that is the applications. Okay, so we shall still come to the application. So I don't want to answer that just to avoid repetition. That's okay,
Oh,
Kennedy?
yeah, that's okay. That's
Yes,
okay. Thank you.
because after every distribution, we'll discuss about what? Its applications, its properties, and also its applications. That's cool. Nice. Good. So if we are together, just show me a thumbs up, please. Kennedy, Ini, good. Jesse, only three, four, five. Eric, six. Kaluki, Benson, seven. Caleb, 8. Can see we are 17 in this class. I've only seen 8 responses. Unless the others we are not together, maybe they are busy somewhere else or busy cooking. Anyway, let me go with that is sample data, all those feedbacks. Okay, those 8 feedbacks. Good. Now let's discuss about skewness. So for skewness, I want to take it very slow so that you may understand this, because this is one of the properties we'll be discussing, like under normal distribution. How is the skewness for or what does the skewness tell us? Okay, what does the skewness tell us? So, of course, remember, for skewness, we usually use that is the standard normal distribution, okay, to show us what? That is the skewness. Let me just do some illustrations here. Okay, so these are just graphs to show maybe that is different skewness we have. Okay, but we shall define that. So Skewness in statistics measures the asymmetry or the deviation of a given random variable distribution from a symmetric distribution like normal distribution. Like for example, when we talk about a perfect normal distribution, okay? When we talk about a normal perfect distribution, okay, then it means that for a perfect normal distribution, it means that the data is perfectly normally distributed. Like any values, okay, let's say the values between on this side and the values on this side, they are almost equal, okay, and we have a line here which is the mean. That is, this line separates, that is the curve, into two equal parts, meaning this side it will be equal to what? To this side. That's a perfect normal distribution. Okay, that's why we are saying that in a normal distribution, if possible, I can say a perfect or maybe a standard normal distribution. We know that median is equal to mod is equal to mean. This is one of the properties of what? Normal distribution. We shall come to see that. Okay? Under the properties of normal distribution, you can see in normal distribution, the mean, the median, and the mode are equal. This is that is a major property when it comes to normal distribution. Okay, so when we are talking about skewness, we usually check now skewness in reference to a standard normal distribution. Okay, so you can see this data is normally distributed, but most of our data is what? Is it's on the what? It's on the right. Okay, here most of the data it's on the what? It's on the left. So we shall do what? We shall go and see. These are the different types of that is skewness we have. Okay, good. Now, skewness in statistics can be divided into two categories. The first one is positive skewness. The second one is negative skewness. Meaning any skewness value less than what? Zero. This becomes what? A negative or a negative what? A negative skewed data. Okay, we can say maybe this data is skewed maybe to the what? Is skewed to the left. Okay, it is skewed to the left or skewed to the that is to the right, depending with what? Depending with the that is how the data is looking like. Okay, then when maybe the skewness is greater than zero, okay, then we say this that is this data, it's what? It's positively skewed. It's positively skewed. When the skewness is zero, then we term that distribution as what? A standard normal distribution. Like for example, let me try to show you that is skewness. Let's say the skewness graphs. Skewness. All right, I guess this. Let me try and see. No, I just need graphs. Graphs will help much. Okay, so let's start with maybe the positive and the negative skewness. Okay, so you can see the what? The negative skewness. So you can see the tail. Okay, the tail is moving to the what? To the left, or the tail is long to the what? To the left. Okay, then for positive skewness, you can see now the tail is long to the what? The tail is long to the that is to the right. Okay, and then we are saying that maybe for negative skewness, you can see we are saying that the left tail is longer. Okay, so the mass of distribution is concentrated on the what? On the right of the that is on the figure. That's very correct. So you can see for negative, the tail it's longer to the left, and most of our data, okay, sorry, most of our data, it's what? It's in that it's in the right side of the figure. Okay. What about the positive? The positive, we are saying that the right tail is longer. You can see the tail is longer here. Okay, meaning that most of our data is concentrated to the what? To the left of the what? To the left side of the curve. Okay, like I had illustrated. Like for example, this one, it's a positive it's a positive skewness. Why? The tail is long to the right, okay, and most of our data is concentrated on what? It's concentrated on the left side, okay, and this one that is we have the that is this will be the negative. Why? Because the lay that is the tail is long to the what? To the left, okay, and most of our data is concentrated to the what? To the right of the what? Of the curve. Okay, that is a summary of what? That's a summary of skewness. Okay, I've just summarized the skewness definition. Okay, with these graphs, maybe for better understanding for those who understand out of what? Out of illustration. So positive skewness, we are saying that the extreme data values are higher in what? Positive, that is in a positive skew distribution, which increases the mean value of what? Of a data set. To put it in a way, a positive skewness distribution has a long tail, okay, to the right side. So you can see the long tail to the what? To the right for positive skewness. Okay, meaning that the mean is greater than the median, and also it's greater than the what? Greater than the mode. Mean is greater than median. Median is greater than what? The mode in what? In positive skewness. These are some of properties of what? Skewness. Like for example, you may be asked maybe in the test, that is, what kind of skewness, okay, that is, or which of the above, or which of the below properties, okay, indicate a normal distribution, okay, and you are given this, and the one for, and this one, okay, three options. So definitely you will go for what? For this one. Why? Because for normal distribution, that is the skewness, it's what? Zero. And median is equal to mode is equals to mean. Okay. But for positive skewness, mean is greater than median and it's greater than mode. Okay. And the skewness value will be what? Will be greater than 0. What about skewness? Negative skewness. So the extreme data values, okay, are smaller in negative skewness. The data values are smaller in negative skewness, which lowers the data set's mean value. So for a negative skew distribution, is the one with the tail or with the long tail on the what? On the left side. This one, you can see the tail is long on the left side. Okay. Hence, in a negative skewness, mean is less than median and median is less than what? Mode. Meaning mode is also less than what? That is mean is also less than mode. Okay. Yes, that's one. That is another property that that is the skew that is for a negative skewness. Okay, and for a negative skewness, the skewness will be what? The skewness value will be less than 0. Okay, yes. Then we have that is that is the skewness formula is called so because the graph is plotted in a displayed that is in a displayed or in a skewed manner. Skewness is a measure used in statistics that helps us to reveal the asymmetry of a probability distribution. It can either be a positive or a negative, irrespective of the sign. Okay, so to calculate this, we usually have a formula. I guess we have formula for kurtosis. What about formula for what? For skewness. Okay. Formula, and remember I can remember I said that skewness is what? Is the third that is derivative from the mean. Is the third derivative from mean or from expectation of what? From expectation of x. Okay, from expectation of x. Maybe let's try and see. That is the skewness formula. Okay, skewness formula. So skewness formula is this one. This is the skewness formula. Maybe I can copy this image to our slide just so that we may have it. So this is our skewness what? Let me keep it here. This is our skewness that is formula. Okay, and it's a third derivative. Okay, it is a third derivative, so you can always maybe check that is see how. Okay, mathematically we derive skewness from the what? Skewness from the expected value of x or from the mean. Okay, all right, good. So for skewness we also have that is an Excel function known as skewness. Okay, skewness, we have a function known as skewness. So if you are dealing with data, you can find maybe the skewness of that data using that that is inbuilt function. So during the practicals, I'll show you how we can do, we calculate skewness in Excel, and then I will also give an exercise on the same. Okay, all right. Maybe just to do an overview of skewness. Okay, let me just do an overview of skewness, and after that, maybe I will also give you a chance, maybe to contribute or to ask any question. Okay, under this, and then tomorrow we'll discuss about kurtosis. If we will have time, we'll also discuss kurtosis today, but if we won't have the time, we'll discuss kurtosis tomorrow and then start with our first distribution. Okay, and our first distribution will be normal distribution. Okay, all right, good. This is just another that is some notes for that is for skewness. Okay, all right. So real life data rarely, if ever, follow a perfect normal distribution. Yes, it is rare for us to get a data which follows a perfect normal distribution. Okay, take note of that. So the skewness and the kurtosis coefficient measures how different a given distribution is from a perfect normal distribution, or how our data is distributed or it's normally distributed. Let me remove the normally distributed, like how our data is distributed, okay, in comparison to a perfect normal distribution. The skewness measures the asymmetry of the distribution. So the normal distribution is symmetric and has a skewness of 0. Yes, I had said so. That is, for a perfect normal distribution, we have a 0 what? Skewness. If the distribution of a data set has a skewness less than 0, then that becomes a negative skewness. Then the tail will belong to the what? To the left. Okay? Then for a positive distribution, meaning the value of skewness is greater than what? 0. It implies that the tail is long to the right, okay, of the distribution, okay, than it is on a left. That's okay. Okay, skewness. So remember we said normal distribution. This is the illustration, or this is how it looks like. It looks like a what? A bell-shaped, it's a bell-shaped distribution. Okay, so in statistics, skewness is a measure of asymmetry of the probability distribution of a random variable about its mean. In statistics, skewness, we are saying that, is measure of asymmetry of probability distribution of a random variable about its mean. In other words, skewness tells you the amount and the direction of the skewness, okay, in what? In a data set. So the skewness value can be positive or even undefined. If skewness is 0, the data are perfectly symmetrical, although it is quite unlikely for real data to what? To be perfectly symmetrical or to have a perfect normal distribution. Okay? And that is in general. Under skewness, we usually use the rule of the thumbs. Okay, if the skewness is less than -1 or greater than 1, then the distribution is highly skewed. Okay, if the skewness is between negative 0.1, that is -1 to negative 0.5, or between 0.5 and 1, then the distribution, or we can say our data, is moderately skewed. Okay, but if now the skewness is between now the negative 0.5 and negative 0.5 and positive 0.5, then the distribution, we say it is what? It is approximately symmetrical. Okay, like for example, let me check. That is perfect normal distribution. Perfect normal distribution curve. Just a minute. Just want to check this one. Can't see the graph. Maybe it's taking some time. So you can see for a perfect normal distribution. Okay, this side from the mean, this side, it's equal to this side. Okay, that's basically, that shows the what? The perfect normal distribution. If this side and this side are equal, then it means the skewness will be 0. Okay, and with that we will talk about what? That is a perfect normal distribution, and then our that is a graph, or our distribution graphical representation will be almost asymmetrical what? It will be almost asymmetrical distribution. Okay, that is for what? That is for skewness. Any question under skewness? Any question under skewness? Have you gotten the concept under skewness? Thumbs up. Are we together? Yes, Jesse, Aini, two people are good. Caleb, Masita, good. Belinda, Kelvin, Karani, can see we have improvement. Yes, Kennedy, Okinda, Eric Otieno, Cyprus, Kaka. Yeah, at least that shows that we are together. And that is those slides were self-explanatory. Someone has a question? Yes, Kaluki?
Okay. So I just wanted to ask, when you're looking at these graphs, which are showing us the positive and the negative skewness,
Mhm.
what is on the x-axis?
Okay, so it depends with the that is your variables. Okay, it depends with
Okay.
the maybe your variables. Like for example, when we are talking about that is normal distribution. Okay, we can say
Mm-hmm.
like what we have in x-axis. It is what? Let's say we have maybe the number of students here, number of students, and we are examining the distribution of what? Of their weights. Then under x-axis, we'll have what? We'll have that is what do we call it? We'll have now the weight in kilograms. Okay, so we will want to see how that is how is our what? How is our all the students' weight distributed? Let's say we have 100 students, okay? So and we have different weights here, like different range of weights. Like we can go with an interval of 10, maybe 20, okay? Or maybe let's go with an interval of 40, okay? So we
Mm-hmm.
are starting maybe with no, 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 just a minute. I want to choose a suitable scale. Okay. So in this case, we might maybe start with 0 and go with interval of 20. Okay. Interval of 20. So we'll go also to 40. We'll also go to that is 60. We'll go to 80, and we'll go to maybe 100 and also 120. Okay, here it's the number of students. Okay, this is the number of
Mm-hmm.
students, okay, within maybe that class. So with this we can find maybe whenever we have we will plot, that is we'll plot the weights of these students along what? Along our x-axis. Okay, even you can just make some x's, okay, over here. Okay, like for example, if we have a student, well, that is the first student has maybe a weight of 20. Okay, you can do a 20. How many students? Let's say we have two students having weight of 20, so you can do xx here, or let's say three students. Okay, so let's say we have also some students with what? 40. Let's say we have five students having what? Having a weight of 40. Okay, so we will have five students here. Okay, under that interval. Let's come. We have maybe majority of the students. Their height is what? Their height is between this part. Like for example, let's say we have maybe 20 students. Okay, who are weighing 60 kgs. Okay, so we'll have most of our students, okay, within what? Within this. And then at the end, we'll now draw maybe a curve along our weights. Maybe let me just show you. That is one application here. Uh, applications of normal distribution. Just a minute, there is, okay, I need this one. So let's go with the height, okay? So we have maybe an example of height. So like the height of people is an example of normal distribution, okay? Most of the people in a specific population have average weight, that is height. The number of people taller and shorter than the average is almost equal and very small of number, okay, are either extremely tall or extremely short. So like for example, in this illustration, okay, you can see we are having few or almost one person or two people with what? Let's say even let me even copy this image and paste it here. Okay, so in this example, let's assume from this part and this part, this side shows extreme that is, it shows extreme what? Okay, just a minute. Okay, so this part shows extremely tall guys, okay, and this side shows extremely what? Short students. Then we have majority of students here. So along the x-axis, you might now put what? The height, okay? Like for example, we have like a specific height. It can be 20, maybe 20 feet, or it can be maybe something to do with, we can start with the height of, I don't want to use centimeters. Let's say even 90 centimeters. Okay. Then go to also 100 centimeters, which is 1 meter, all up to maybe 150 or 170 centimeters. Okay, so you can see majority of our what? Majority of our students height, okay, fall under this range. Okay, maybe the range between 154 centimeters to 170 centimeters or to 160 centimeters. Okay, majority fall under this part. Okay, so that's why we have in maximum, or we have in this curve, okay, all this peak between what? Between the point where we have the maximum weight. The same as my, that is the weight, that is example. We'll have most of the students weighing between maybe 50 and 80 kilograms, okay? Then we'll have some few students who have less or extremely small what? Extremely small weight, and also others with extremely what? Extremely high weight. Okay. So basically, what you want to keep on the, that is on the x-axis, it's the variable which you are trying to what? That is you are trying to plot against the total number of students. But I guess this picture, this one, better explains or better shows you that is the what? The distribution. It's like the same for rolling a dice, that is a dice. Okay, you can see the number of rolls we are making. Also tossing a coin, and also an IQ. This is an IQ or intelligent quotient, maybe survey or competition. So you can have that data that is plotted. We also have technical stock market, and then we also have blood pressure, okay, measure, and also the shoe size, okay, the shoe size. So you can see we have along the axis, the x-axis, we are having what, the shoe size. Then along the that is along the y-axis, it's like we have the distribution, either in terms of the percentage of the total population, or you can go with the individual what, count. Okay, same to birth, that is the birth weight, and also student average report. Okay, that is the mid performers, the high performers, and low performers. Okay, that's clear. That's clear. Is that clear, Rose? It was
Yeah, it's clear.
Rose Bell. That's clear.
Yeah. Yes. Yeah.
Okay. Any question? Any addition? Are we together up to that point? I would like maybe to stop at that point and then start on kurtosis tomorrow. So for kurtosis, we will be now dealing with what? The thickness and the thinness of the what? Of the tails, okay, into comparison to what? To a perfect normal distribution. Okay, yes, like you can see, let's assume this is the perfect normal distribution. Okay, you can see here we're having a standard thinness of the what? Of the tails. Okay, so we'll be now checking what about when we are having thicker what? Thicker tails. Okay, or when we are having what? Thinner tails. What will be happening to the mean, okay, and what? Standard deviation. So with this, we will control this thinness and thickness of that is of the distribution using mean, or controlling with mean and standard deviation. Remember, these are the some of the factors which we say they determine the shape of what? They determine the shape of a distribution. Okay. Yes, so we shall discuss about kurtosis tomorrow, and then we'll also get opportunity to start with the what? With our first distribution. Okay? All right. Otherwise, how so far, how is the going? I would like to get a feedback. So far, how is the going? How is the going? I would need maybe a comment on the chat area, like under distribution. Are we good? Okay. Are you getting? Yes or nice? Any? You are doing good. Belinda, thank you for taking your time on Skewness. Nice. Yes. What about the others? Eric, we are all good. Kennedy Okinda, for me, I'm learning new things every day. So it is an achievement. Wow, nice. Caleb is fairly straightforward. Good. Belinda, it was a bit confusing before, but now I understand it. Wow, nice. It means maybe I've taken some time explaining that. Then we have Jesse, all good, all good. Yeah, let me take that those reviews or feedbacks for now. That's awesome. Thank you, guys.